Jai Hind. My name is Vaishali Deshwal, and currently I'm working as an assistant professor at AKGEC, Ghaziabad. Today is the fifth lecture on artificial intelligence, and today's topic is natural language processing. So, let's start with the definition. So, NLP, it stands for natural language processing. It refers to the branch of computer science, and most specifically the branch of AI. So it is concerned with giving the computers the ability to understand the text and the spoken words in a similar way as the human beings can. And it derives the computer program that can translate the text from one language to the another, respond to the spoken commands, and summarize the large volumes of text rapidly in even in the real time. So there are some terminologies. For example, machine translation comes under the NLP, and what does it mean? It refers as a subfield of computational linguistics that investigates the use of softwares to translate the text or speech from one language to another. So this is the machine translation, or we can say which is used to translate the text from one language to other. So on the basic level, it performs a simple substitution of the words in one language for words in another. For example, if I want to convert any sentence from English to French, so there will be the word substitution, the simple word substitution there will be. So, but that alone usually cannot produce a good translation of a text, because the recognition of the whole phrases and their closest counterparts in the target language is needed. So, the recognition of the whole phrases and the closest counterpart. So, the recognition of these things is very important. Alone, the substitution of the word doesn't suffice. Next thing is that solving this problem with the corpus statistical and the neural techniques is a rapidly growing field in this, that is leading to better translations, handling the differences in linguistic topology, translation of idioms, and the isolation of anomalies. So to solve this problem with the corpus statistical, this field is quite important. Next subtopic in NLP is machine translation. So we have already studied that what is the definition of machine translation and what MT refers to. So now we are going to see this particular term in detail. So MT, or machine translation, is the automatic translation of text from one natural language to another, means from the source to the target, and that is the machine translation in very simple or the basic terms. The translation is very difficult, and it requires in-depth understanding of the language. A translator, it can be a human, it can be a machine, and it often needs to understand the actual situation which is described in the source, not just the individual words. Sometimes the words, they're saying something else and the situation is something else. So the words, they are used in what context. It is very important to understand that context, that okay, these sequence of the words, they are used in these particular sequences. For example, if we are just considering the word open, so this is a sentence, this is the first sentence, as you can see here, that open on the door of a store. So it communicates the idea that the store is accepting the customers at that particular moment, and that is where the statement is, that open on the door of a store. So it's an example that a particular word, open, is used in the two different sentences, but it conveys the different meaning. So in the first one, it communicates the idea that the store is accepting the customer at the particular moment. And now consider the same word open, but in the other sequence of the word, that is open on a large banner outside a newly constructed store. So it means that the store is now in daily operation, but the reader of this sign, they wouldn't feel misled if the store closed at night without removing the banner. So there are two words, but they signifies the different meanings. So the signs, they use the identical word to convey the different meaning. So it is very indispensable to understand the context in what context the words they're written there, or what a particular sentence is try to convey. Now there are three main applications of MT, or you can say machine translations, and these are rough translation, pre-edited translation, and restricted source translation. So rough translation is as provided by the free online services, that is the gist of the foreign sentences or the documents, but contains the errors. Pre-edited translation, it used by the companies to publish their documentation and the sales materials in the multiple languages. And the third application of the MT is restricted source translation, that works fully automatically but only on highly predictable language such as weather reports. Next, so again, there are two systems. First is MT system and second is statistical machine translation. Now the first is machine translation system. So all the translation system, they must model the source and the target language. The target language is the one in which I or anyone want to convert the language to. Some systems, they attempt to analyze the source language text all the way into a interlingual knowledge representation, and then generate the sentences in target language from that representation. So these are the steps in the MT systems. Firstly, one has to just analyze the source language text all the way, and secondly, it has to generate the text in the target language. So there is a source language, there is a target language. For example, if someone wanna convert a sentence in English to a sentence in French, so English sentence is a source language, or or we can say it's a source text, and we want to convert it into the target language, that's a French language. So these are the two steps in this. Then it is very difficult because it involves the three unsolved problems. And what are these? First problem is that creating a complete knowledge representation of everything. We have to just represent everything. Create the complete knowledge representation of everything, and then only we can be able to do the translation. And the second thing is parsing into that representation. So first we need the representation, secondly we need the parsing, and third we generate the sentences from that representation. So we should be able to generate the sentences from that representation. So these are the main difficulties while we are just building or creating the MT systems. Next we have the machine. This is a continuation of MT systems. So it keeps a database of the translation rules. For examples, the translation rules, they can be the examples. For example, like in one sentence, if there is a word and like is, and there is another word which is used for is, so this is the example, this is the rule set, and the data set of such rules is kept, and whenever the rule or the examples matches, they translate directly. So transfer can occur at the lexical, syntactic, and semantic level. So these are the levels on which the transfer can occur, and this is called the transfer model, and it comes under the machine translation systems. So let us see an example. For example, transfer the English to French. So English language is a source language and French language is a target language. Look, you need to understand that what is the source in the and what is the target language. So for example, a strictly syntactic rule maps. So here, as you can see, English adjective noun to French noun adjective. What does it mean? It means that if in English we are writing adjective noun, then in French we have to write noun and adjective. You need to just understand the order, that in English we are writing adjective and then noun, and in French we are just writing noun first and then adjective. So this is the syntactic rule, and this is how the syntactic rule maps. Then a mixed syntactic and the lexical rule maps. For example, French S1, it use S2 to English S1 and then S2. Means ET, for ET we are using and And for PUIS, we are using then in English sentence. So these are just the substitution of the words. Now, this is a diagram, and this is called a triangle, a symmetric diagram of the choices for the MT system for John loves Mary. So John loves Mary, it's a sentence and it's a English and it's an English language, or you can say these are English words. So these are the levels here. Firstly, we are just converting these English words to the English syntax, and then English semantic, and then interlingua semantic, and then French semantic, and then French syntax, and then French word. So these are the levels, and we are just going in this way. We are just following these steps in this way. Firstly, this is a John loves Mary. So we have to convert this word in this representation, that is called English syntax, and then we have to convert this into this relationship here. We are writing loves John Mary. It means John loves Mary. John loves is a relationship. So we write loves and then bracket John, comma Mary. So this is the English semantic, and then we go to the interlingua semantic, and again we come here, and finally we get the word in French, or we get the French words. So start with the English text at the top, and the interlingua based system follow the solid lines. As you can see here, these are the solid lines. So follow these solid lines, parsing English first into a syntactic form. As you can see here, syntactic form, and then the semantic representation we have to create, and then interlingua representation. And when we reach to the interlingua representation of the English word, which we want to convert it into the French language, then through generation to a semantic, synthetic, and lexical form in French, we are able to convert it. Okay. So the transfer-based system uses the dashed line as a shortcut. So instead of just using these solid line, the transfer systems is using these dashed lines as a shortcut. Means for that these are the words in French for these words in English. Okay, so the different systems, they make the transfer at the different points, and some make it at the multiple points. So this is the basic semantic diagram. Next, we have statistical machine translation. So we have seen the machine translation systems and what are the steps involved in it, what are the difficulties which are involved in the machine translation systems, and now we are going to see statistical machine translation. So let's start. Let's suppose that there is an English sentence and E. Finding a French translation F. So English sentence is E, it is represented by E, and then the French, we want to find a French translation, that is F. So it's a matter of the 3 steps. First, we have to break the English sentence into the phrases, that is E1 to En, and then for each phrase, EI, we have to choose a corresponding French phrase, that is FI. And then we use the notation, that is P, FI, EI. What does it mean? It's a conditional probability for the phrasal probability that FI is a translation of EI. So it's look like conditional probability, and you can just understand by this particular notation that FI is a translation of EI. And then in the third one, you have to choose a permutation of the phrase, that is F1 to Fn. So these are the 3 steps which you need to follow in order to have a conversion or the translation from the English sentence to the French. So for each FI, we choose a distortion, DI. So DI is, we are using the symbol DI for distortion. And what is distortion? Distortion is the misrepresentation, which is the number of words that phrase FI has moved with respect to FI minus 1. So we're going to see an example here, and by that example you will be more clear about it, that what is distortion, what is minus 1, what is plus 1, what we are doing actually. So for misrepresentation, there are certain rules, and the rules are like that for the positive we are moving to the right. So if we are moving to the right, then we are going to assign some positive number. And if we are going to the left, then we are going to assign some negative number. And 0 if the fi is immediately following the fi minus 1. So there are the three values, positive, negative, and the 0. And if the word is shifted right, then we are going to assign positive. If the word is shifted left, then we are going to assign negative. And if it immediately follows the fi minus 1, then we put 0, or there will be no shift. Okay, so this is a concept of distortion, that is represented by di, and that stands for misrepresentation. Okay, so here is the procedure, that this is the procedure for statistical machine translation. If we want to convert any sentence from any language to any other language, then we need to follow a procedure, and these are certain steps. So total there are 6 steps. First is that we have to find out the parallel text. Suppose I'm having a sentence in English language, I have to find out a parallel text in, and suppose the target language is the French. So firstly, I have to find out the parallel text in the French one. Now, second is the segment into the sentences. Means the unit of the translation is a sentence. So we'll have to break the corpus into the sentences, because the unit of the translation is the sentence, and that is the reason that we are breaking the corpus into the sentences. So periods are the strong indicators of the end of the sentence, and third step is that we have to align the sentences. So second is segmentation. Third is the alignment. For each sentence in English version, determine what sentence it corresponds to in the French version. And fourth one is align phrases. That within a sentence there are certain phrases and they can be aligned by a process that is very much similar to that used for sentence alignment. So we are going to do 2 alignments here. First is the sentence alignment, and second is the phrase alignment. And then we have to find out the misrepresentation, that is the distortion, or you can say D. So expect the distortion. So count how often the distortion occur in the corpus for each distance. It can be which can be represented by the values. It can be 0 if there is no movement. It can be +1. It can be -1. So the value can be positive, negative, or the 0 based on the movement or the distortion. And then we have to apply the smoothing to correct that. Sixth is improve the estimates with EM. EM is expectation maximization. It's an algorithm. So we have to improve the estimate with it. Used to improve the estimate of PF by E and PD values. Okay. So as you have studied that, what does it mean? PFI by EI. It's for the phrasal probability that FI is a translation of EI, and FI is a French phrase, and EI is the English sentence. Okay, so E step is, that is the expectation step, is that compute the best alignment with the current values of these parameters. And the second is M step, that we have to update the estimates and iterate the process until convergence. So this is a simple example, and in this we are just following the procedure. As you can see here that this word is moving this side. So we are assigning -2, and this word, as there is no change here, so we are just giving it 0, and still there is no change here, then we are giving it 0 value. So this is a sentence in English, this is a sentence in French, and we just want to convert this sentence into the French language. So if there is a movement, if we move right, then we assign some positive value. If we move left, then if there is a movement of the word to the left, then we assign some negative value. And as for example here, and if there is no movement, then we assign the D value as 0, because there is no movement, the distortion is 0. So the procedure is that you have to find out the parallel text. Second is segment into the sentences. Third is align the sentence, align the phrase, and then extract the distortion, the D or the misrepresentation value, and then improve the estimate with EM, means the expectation maximization steps you have to follow it to improve the estimates. Next topic is speech recognition. So speech recognition क्या होता है? Speech recognition is the task of identifying a sequence of words spoken by a speaker given the acoustic or audio signal. So this is a simple or the basic definition in which you can define or by which you can define the speech recognition. So it has become one of the mainstream application of AI, as you know, and million of people, they're interacting with the speech recognition systems every day. Why? Because of many reasons, and some of them I have listed here. So these are like to navigate the voicemail systems. Second is search the web for from the mobile phones and voice text conversion, and there are many more applications like this, and because of which the speech recognition systems, they are in demand. Speech is an attractive option when hands-free operation is necessary. If we want to operate any machine hands-free, then speech is the very attractive option as when operating the machinery. Okay. Next thing is that speech recognition is a software program accept the sound as input and convert it into the written language, both the computers and humans can understand. And it uses the 4 steps to convert the speech to text. So as you know, by the definition of speech recognition, that it's a task of identifying the sequence of the words spoken by the text speaker. So from the speaker, the words which are spoken by the speaker, we need to identify the sequence of the words. So here we are using 4 steps to do so, to convert the speech to the text. First thing is that you have to analyze the audio and then break it into the part. Third is digitize it into a computer readable format, as you have to convert the speech to text. And lastly, you have to use an algorithm to match it to the most suitable text representation. So these are the 4 steps which are followed in SR, in speech recognition. That's a computer program which accepts the sound as input and convert it into the written language. So the basic or the main aim of the speech recognition system is to convert the sound into the written language, or you can say the text. There are certain issues in speech recognition. So there are we have studied that what is the speech recognition, what are the examples of speech recognition, what is the procedure, what are the steps involved in it, and now we're gonna see that what are the issues in speech recognition. So speech recognition is difficult. Why? Because of many reasons. First is that because the sound made by the speaker can be ambiguous and sometimes can be noisy. As a well-known example, the phrase recognize speech sounds almost the same as rack a nice speech. So recognize speech and the other sentence is rack a nice speech. So while spoken quickly, the sounds almost the same. So it is very difficult to convert such type of the sentences into the text, because in sound they are almost similar, but they are totally different sentences. So this is the major issue in speech recognition. Then segmentation. Written words, they have spaces between them, but in past speeches there are no pauses. For example, in recognize, that would distinguish it as a multi-word phrase as opposed to a single word, recognize. So the segmentation problem is there. Then co-articulation. Co-articulation means that when speaking quickly, the S sound at the end of nice merges with the B sound of the beginning of beach. So the end sound of a particular word, it merges with the starting, or you can say the beginning sound of the other. It is referred as co-articulation, and L is something that is close to a sub. So here I have mentioned an example. Co-articulation means that when the end sound of a particular word, it merges with the starting or the beginning sound of the another word. That is the co-articulation. And when speaking quickly, the S sound at the end of the night. This is just an example. Okay. Now we have homophones. So homophones, the words like to, TOO, this is also 2, and TWO, this is also 2. So we have these 3 2, and they have different meanings, but in speaking, while I'm speaking these words or while I'm saying these words, they sound same. So that sound is same, but they are different in meaning. So these are the homophone, and this is the issue in speech recognition. That if a person is saying this too, then how we can convert it into TOO, because it can be TWO. How do we know that it's TOO, not TW or TO? So this is a problem of homophones. Then there are three models: noisy channel model, acoustic models, and language models. So first we'll see these models one by one. First is noisy channel model. Noisy channel model is that when an original voice message is transmitted over a noisy channel, let's say it's a telephone line, such as a corrupted message are received at the other end. A ceiling fan is about 5,000 times more likely as the word sequence than ceiling fan. So they're very similar to one another, only there's a difference in spelling, you can say. And it is possible to recover the original message with small error if we encode the original message in the written in enough way. So the applications are speech recognition, MT, and spelling correction, and the other tasks. So this model is that when you are just transferring a message over the noisy channel such that the corrupted message is received at the other end. So this is the noisy channel model. Second is the acoustic model. Acoustic is that let's say sound waves. Sound waves, they are the periodic changes in pressure that propagate through the air. Since we only want to know that what words were spoken, not exactly what they sounded like, so we need to distinguish between the speech sounds. Like linguistics, they have identified about 100 speech sounds or the phones that can be composed to form all the words in all the known human language. A phone is correspond to a single vowel and consonant, but there are many, or you can say some complications. The combination of letters such as th, the, and ng, they produce the single phone, or you can say sound. Now, identifying the variation in sound is very important. It can be loud, it can be soft, fast, slow, male, female voice, etc. So identifying the variation in the sound is very indispensable. And this is the acoustic model says that the speech systems, they translates the acoustic signals into the sequence of frames, like the time slice of the signal, as you can see in these diagrams or in the figure. So in this diagram, each frame is described by discrete values of the three acoustic features, and a real system would have the dozen of features. And the overlapping of the frame, as you can see here, there can be the overlapping. So, and the overlapping frames, they are used to make sure that we wouldn't miss a signal, because it happens to fall on frame boundary. Okay, so overlapping frames, they are used to make it sure that we don't miss a signal. Last is the language model. Language model can be an n-gram model. We have studied that what is an n-gram model, and language model is quite similar to it, or it can be this model of the text learned from a corpus of written sentences. The spoken language has different characteristics than the written language, and for task specific speech recognition, the corpus should be task specific. To build your airline reservation system. Okay, so this is just an example that if someone wants to build the airline reservation system, then the speech recognition, it also helps to have the task specific vocabulary that would be same to that in those tasks. Suppose there is an airline reservation system, so if the vocabulary is related to this system only, then it can be applicable to any airway, any airline reservation, a list of all the airports in the city served and all the flight numbers. So if the corpus should is the task specific, then it should be helpful, or you can say applicable, while we are gonna deal with such systems, such task specific systems. Building a speech recognizer. The quality of a speech recognition system depends on the quality of all of its components, and these are the language model, the word pronunciation model, and the phone models, etc. The single processing algorithms used to extract the special features from the acoustic signal, and the large pronunciation dictionaries that are available for English and the other language, and although their accuracy varies greatly. Okay. So here the quality depends on the quality of all the components, and these are the components. And the signal processing algorithms, they try to feature, and we use these algorithms to extract the features from the acoustic signals. Now, is it easy to build a system from the corpus? So building a model from the corpus is more difficult than building an n-gram model of text, because we have to build a HMM, hidden Markov model. It is very much important. So the phone sequence for each word and the phone state for each time frame are hidden variables. And recent systems, they use expectation maximization algorithm to automatically supply the missing data. So the systems with highest accuracy work by training a different model for each speaker, and thereby capturing the differences in language as well as male, female, or the other variations. Now this training can require the several hours of interaction with the speaker. Now, what is the accuracy of a system? Accuracy of a system depends on the number of factors. For example, I have listed these factors. First is the quality of the signal, matters a lot. And vocabulary size also matters. Third is task also matters. And the last is the accuracy of the system. It also depends on the quality of signals to the extent possible. So a high dimensional directional microphone with a stationary mount in a plated room will give high accuracy in comparison to a cheap microphone, because cheap microphone transmitting a signal over phone lines from the car in traffic with the radio playing produces poor quality. So it is very much understandable, or it is very much as you can say, by just referring to the words like cheap microphone and high quality directional microphone, one can easily say that high quality directional microphone will give high accuracy in comparison to the cheap microphone. And now we have this vocabulary size and these tasks. These are the factors on which the accuracy of the system depends. And while we talk about the vocabulary size, then when recognizing the digit strengths with a vocabulary of 11 words, 1 to 9 plus O plus OH and the 0. So the word error rate will be below 0.5%, whereas it rises to about 10% on news stories with a 20,000 words vocabulary, and 20% on the corpus with 64,000 words vocabulary. So this is the data, you can say. And you can say that the accuracy highly depends on the vocabulary size. So while recognizing the digit strings with the vocabulary of 11 words, so the error rate is below 0.5%. And when it rises to 20,000 words vocabulary, then the error rises above 10%. So that is quite high. And with the 64,000 word vocabulary, it is 20%. So vocabulary size does matters. And last is the task. So when the system is trying to accomplish a specific task like booking a flight or give direction to a restaurant, so the task can often be accomplished perfectly. Okay. Now this is it. this is the machine translation, the statistical machine translations, and natural language processing. These subtopics, they comes under natural language processing. Now the next thing is robot, and in robot we'll study that what is hardware, what is perception, what is planning, and what is movable parts, you can say. So let's start by understanding that what is a robot. So if we see the definition, so these are the agents, physical agents, that perform the task by manipulating the physical world, and to do so they are equipped with the effectors, for example with the legs, with wheels, with joints, and with grippers. So effectors, they have a single purpose: to exert physical force on the environment. There are many terms like environment, state, effectors, and we have already discussed all these terminologies. Fourth point is that robots, they're also equipped with the sensors. You already know what are the sensors, and which allow a robot to perceive the information, the knowledge from the environment. So they have effectors, they have sensors, and for some purpose, like to sense something from the environment and to assert the physical forces on the environment. Now, there are some more points about robot. So fifth point is that present day robotics employs a diverse set of sensors, and including the cameras and the lasers to measure the environment, and gyroscopes and accelerometers to measure the robots on motion. So there are many equipments to measure the robots on motion. And most of the today's robots, they fall into one of the primary category. First is the manipulator, or you can say the robot arms. They are physically anchored on their workplace, for example in a factory assembly line or the International Space Station, or you can say ISS. Now, the second topic is robot hardware in robot. So we are studying this major terminology, that is robot, and the second subpart is the robot hardware. So in robot hardware, sensors, what are the sensors? Well, sensors, they are the interfaces between the robot and the environment. And there are some passive sensors, for example cameras. They're the true observers of the environment, and they capture the signals that are generated by the sources in the environment. Active sensors are there. So the sensors, they can also be divided into the two categories. First is active sensor, and second is passive sensor. So active sensors such as sonar send energy into environment, and they rely on the fact that this energy is reflected back to the sensor. So the active sensors, they tend to produce more information in the comparison to passive sensors. So just remember that this is about that what are the basic differences between the active and the passive sensors. Okay, so active sensors, they provide more information than passive, and at the expense of increased power consumption and with the danger of interference when making active sensors are used at the same time. Whether active or passive sensors, they can be divided into three types depending on whether they sense the environment, the robot location, and the robot internal configuration. Now, there are some terminologies like range finders are there, stereo visions are there. Okay, so range finders are also the sensors that measure the distance to nearby objects. And in the early days of robotics, robots were usually equipped with the sonar sensors. Sonar sensors, they emit the directional sound waves which are reflected by the objects with some of the sound making it. Next, we have stereo vision. So they rely on multiple cameras to image the environment from slightly different viewpoints and analyzing the resulting parallax in these images to compute the range of surrounding objects. So for mobile, ground, robot, sonar, and stereo visions, they're not rarely used because they're not reliably accurate. Okay, So the usage is limited. Other range sensors, they use the laser beams and special pixel cameras that can be directed using the complex arrangements of the mirrors or rotating elements. And these sensors, they are known as lidars. As you may heard about these things, that what are the lidars? Lidars stands for light detection and ranging, and such type of the sensors, they are known as scanning lidars. Now, the other common range sensors including radars, which is often the sensor of choice for UAVs, that is ultraviolet uh, radiations, and the radar sensors, they can measure the distances of multiple kilometers. On the other extreme end of range sensing are tactile sensors. So in these points, I am discussing that what can be the different types of the sensors, what is the basic difference between the passive and active sensor, and there are many examples of the sensors. So if you are asked a question on sensor or write a short note on sensors, then you can just list these points. So here, radar sensors, they can measure the distance of multiple kilometers, and on the other extreme end of the range sensing are the tactile sensors. What are the tactile sensors? For example, whiskers, bump panels, and touch sensitive skin. So these sensors, they measure the range based on physical contact and can be deployed only for sensing the objects very close to robot. Now, the second important class of sensor is location sensors, and most location sensors, they use the range sensing as a primary component to determine the location. Outdoors, GPS stands for the Global Positioning System, is the most common solution to the localization problem. So this is also the important class of the sensors, and that is the location sensor. The third important class is the proprioceptive sensors, which inform the robots of its own motion. Okay, so these are the sensors of interest, and to measure the exact configuration of a robotic joint, motors are often equipped with the shaft recorders that count the revolution of motors in small increments. And lastly, we have inertial sensors such as gyroscopes that rely on the resistance of mass to the change of velocity, and they can help reduce uncertainty. So this is it for today. We have discussed many topics like MT, machine translation, statistical machine translation, what is a procedure for the translation of for the conversion of the languages, you can say. And then we have studied that what is the speech recognition systems, what is a procedure, what are applications, what are some of the difficulties in doing so, and then various models of it. And then lastly, we have discussed robots. What are the robots? What is the robot hardware? What are the sensors? And what are the different types of the sensors? So this is it for today, and in the next lecture, we'll be discussing robot perception. So thank you.